Good afternoon. Thank you, Langdon and everybody at Innova-Con for inviting me to speak, as well as for organizing such an amazing event. And yes, I apologize for missing this morning. My flight out of Toronto was canceled last night due to snow, which led me to have an early flight this morning and caused me to what I can only describe as excavate my car out of a few feet of snow at 5 o'clock this morning. Thank you to everybody here for taking the time to join me, and I'd also just like to mention, I believe a fellow rLooper is here, Sabine. Oh, there she is, who has authored a book called the Nerdy Martini, Where STEM Meets Passion. You can check it out on Amazon. I am here to talk about the community that we built at rLoop, the work that we did on the HyperLoop, as well as other projects that we're working on, as well as the unorthodox way in which we organize and do our work. But in order to paint the whole picture, I'll need some context. Some of this is probably redundant for this audience, but I'd like to highlight some of the themes that recur throughout my talk. And the first is this idea of innovation as a resource, and I truly believe it to be a limitless one. We face a lot of challenges from the global to the local scale, but we have faced and overcome similar and seemingly dire challenges in the past. And we have this unique capability as humans, when we're confronted with a challenge or a problem, to be absolutely driven to overcome it. And we innovate to create new solutions. And when those solutions or technologies come online, they demand that we change our behavior. We may change the way that we act, we change the way that we interact, and in some cases, our moral and ethical frameworks may need to shift. And that new reality then presents us with a new set of challenges and problems, which of course are also opportunities. And I would argue that this cycle has been true historically and will generally continue to remain true, at least for the foreseeable future. But what is changing is the pace is accelerating. And this is largely due to the exponential growth in technologies, and technologies on that exponential curve, where they intersect, they actually introduce multipliers to that growth. But we have a cognitive inability as humans to understand and perceive the exponential. And when we're confronted with such rapid change, the natural reaction can be anxiety and fear. And we see this reflected in the media and in pop culture with these increasingly dystopian portrayals of the future. But I'm excited about the future, and I think there's good reason for you to be as well. I'd also like to touch briefly on how we structure our organizations today and the paradigms that I see impacting this construct that we call the corporation. So we organize our organizations on a set of top-down hierarchical structures that were designed for command and control. And these systems evolved for hundreds of years to effectively manage assets and people in an effective way, but also in a structured environment, or in a stable environment, I should say. And they're not set up for agility or flexibility, and that's a structural issue. But what we're seeing is a move to a much more decentralized archetype. And Ronald Coase, who was a British economist, and he actually won the Nobel Prize for his work on the nature of the firm, identified one primary reason that we have the corporate structure, and that's to lower transaction costs. So we can bring many elements under one organization, we can lower the costs, we can create a margin that we can mark up and that we can sell. But with the exponential growth in technologies comes not just an increase in performance and miniaturization, but also price performance increase or a decrease in cost. And to give you a look at what this looks like, we looked at the cost of some technologies, and you can see here the cost of computing power over the last 100 years, measured by millions of instructions per second. And if you see today, we're just above the $0 mark. But if you go back to 1983, which is the year I was born, if somebody wanted something with the computing power of an iPad 2, it would have cost them 360 years worth of wages. And so you can see why this is such a profound change. And by the way, if you look at a variety of technologies, you see a recurring trend. This is the cost of light over the past 700 years. This is the cost to sequence DNA, the cost per genome over the last 15 years. And this is the cost of solar modules. So you can see consistently the trend line is driving those costs down to near zero. And now those elements that were previously exclusive become accessible to just about anybody. And finally, I'd like to touch on this quote from Alekis Agonis, who was the original designer of the Mini, the car, who said, "An expert is someone who will tell you why you can't do something." But what we're seeing is a rise of individuals, entrepreneurs, communities, and organizations who won't say no. And we're seeing it in biotech, in neuroscience, in drones, and in blockchain. And the reason that this is so important for innovation is where those experts may have stopped, these communities and entrepreneurs will not take no for an answer. And so my argument is that with the exponential growth in technologies, the cost driving down to near zero, those elements becoming accessible to near everybody, and the market's shifting, that we're seeing a radical transformation of these hierarchical structures that we've become familiar with. And the fundamental purpose, according to Ronald Coase, why we have the corporation today, we could argue, is no longer relevant. And the blockchain actually allows a new type of organization to exist known as the Decentralized Autonomous Organization, or DAO. A DAO is an organization that exists without managerial hierarchy, but that solves the problems of effective coordination and collaboration that were previously solved by the firm. So now dozens or hundreds or thousands of people can create a company that exists virtually without needing to trust each other or even to know each other. And a DAO does this by distributing risk and reward amongst participants, by incentivizing productive contributions, and by dissuading or penalizing malicious activity. Bitcoin, we could actually argue, is a prototypical DAO. There's no central authority who is issuing Bitcoin. Rather, it distributes equity in itself to manage its workforce, who are the miners that the network relies on to operate. And it does this proportional to the contributions that those miners provide. So in that sense, I could argue that Bitcoin proved that we could align incentives using software alone. And then Ethereum came along, was founded in my hometown of Toronto, and kind of blew the lid wide open on it by offering a much more generalized platform to allow people to coordinate around value creation beyond just currency. So Bitcoin, or any cryptocurrency, is just one type of application that you could build on Ethereum, but the platform is much more generalized. And so several years ago, let's make this jump, I was fortunate enough to co-found and be involved in the organization of just such a community. And it all started with a single project, which was the HyperLoop. By show of hands, who here has heard of the HyperLoop? A lot of people, great. So just for those who aren't aware, it's a new method of transportation that was open sourced by Elon Musk in 2013. And the idea generally is to create a very energy efficient system by eliminating the greater losses that all transportation systems experience. So we do this by levitating a vehicle off of the ground to eliminate rolling resistance. And then we put that vehicle in a tube or in a tunnel, and we can control the environment then in that tube or tunnel, and we can optimize it for our purposes. Namely, here we are evacuating most of the air out and creating a partial vacuum, so we're eliminating air resistance. And the result is an energy elegant system that can travel at immense speeds, the anticipated max speed being 765 miles per hour or 1,200 kilometers an hour. And in 2015, SpaceX announced that they were going to build the infrastructure to test vehicles of this type, and they were going to open up the designs to student and independent engineering teams for the possibility to test your vehicle on their infrastructure. They built a 1-mile tube outside their headquarters at Hawthorne, California. And someone on the SpaceX subreddit made a post suggesting that our community form a team to enter, and rLoop was born on that day. And we started to collaborate. We started very modestly. There was a couple dozen people, engineers, students, people working at NASA and Tesla, as well as people retired from industry. And we had to develop ways that we could collaborate on these complex and interdependent systems. And we started, just a couple dozen of us, to design our vision for a HyperLoop vehicle. And after 9 months, we had to travel to Texas A&M University to defend our designs to a board of Tesla and SpaceX engineers. And that was 9 months after we'd started, and there were approximately, the team had grown from a couple dozen to about 150 people at that point. And 9 of us flew to Texas to present our designs. That was the first time any of us had actually met in person. And from an initial 2,000 entrants, we were selected amongst 140 to go and present. And to our surprise, we were chosen to advance to build our vehicle and to test it at the facilities that SpaceX had built. And then we were presented with a new challenge then. While we were able to collaborate on this complex system virtually, now we had to actually translate that work into a physical functioning prototype. But again, not ones to stop or say no. We set about mobilizing an in-person manufacturing team in Menlo Park, California. We partnered with a company called TE Connectivity who gave us lab space there. And we developed different systems to connect our engineers and designers who were distributed all over the globe with this in-person manufacturing team. And we actually used technology very similar to what was just demonstrated, AR/VR for education purposes. We use this to actually work on full-scale assemblies of our full-scale prototype. And what we saw was we had a couple dozen in-person manufacturers, but the distributed team started to take time off from their lives and fly into California to work for a couple weeks as they could on the vehicle. And to give a sense of what the atmosphere was like, I brought this video. Hopefully we can get it to play. No, it was not. Here we go, it's coming up, great.
If you think of how much you can travel in a single day, you can drive, you can take a flight, but there's a limit to that. But if you can change that factor, you can effectively change human lives.
So the HyperLoop is a concept where you have a tube in which you remove most of the air, and inside the tube you have a pod, like an aircraft cabin basically, that is levitating inside the tube, and you shoot that cabin at very high speed.
Really, when you break it down into parts, it's not that daunting. Everybody has their own little specialty, and we're all able to talk with each other pretty easily. That conversation's all had on Slack. You have like basically a distributed network of brains tackling the problem, isolating it, breaking it down to small parts, and then farming those parts out to the rest of us.
Everybody has a piece to the puzzle. We have one guy in China that does amazing design. We have one guy in Alabama that can do aircraft body. I have a guy in Australia that used to do electrical safety critical components.
We are creating a benchmark in how people from all around the world can come together with technologies like Slack and solve any kind of problems you can think of.
I don't know if you could tell, but Slack is one of our sponsors, so thank you to Slack. So, it was nearly 2 years from the time that we formed that we completed building our first prototype, and we're testing it at SpaceX. And I love this photo because this is the largest in-person meet of rLoopers. It was 65 people from 18 different countries. who'd worked together for nearly 2 years and never met in person, and had worked on this project for 2 years and may never have touched the hardware itself. And of course, we were able to demonstrate it to the man who'd originally open sourced the concept, Elon Musk. Next to him in the red cap, there is Steve Davis, who's the Director of Advanced Projects at SpaceX. I am beside him, very sleep deprived at that point. And I'm peering over the shoulder of Tom Lambo, who is our lead engineer on the project. And our vehicle actually, the constant feedback that we received from SpaceX was that it was the most advanced vehicle that they had seen. And we demonstrated several firsts in the space. We were the first to demonstrate static levitation in a vacuum. So we have a unique magnetic levitation system to allow the vehicle to hover, where we can turn the vehicle on and it will hover in place. And this is different than a maglev train that requires a certain translational speed before it interacts with the track and levitates. And we demonstrated that in a vacuum. We're also the first, and to date, the only pod with a pressure vessel. And it was actually built to FAA regulations for business jet class. That was tested in the vacuum and capable of supporting human life. We also believe it's the first engineering system that was entirely designed and built by the crowd. So we did it once. We actually went back and took a lot of data and info from that session, and we rebuilt our prototype. And we kind of joke that we built a car before there were roads, because we're kind of beholden to SpaceX now to test our vehicle on their facilities. But many within the community said, great, that was a great project. What are we working on next? What else are we going to do? And while we have various projects in various stages of maturity at this point, we're currently building our second full-scale prototype for a project that we're calling the R-Flight project. The vehicle is known as the R-Wing. It's designed to be a motorcycle for the sky, a new way for personal to experience flight as an individual. And this is actually done in competition, a competition that's sponsored by Boeing. And our full scale, we have two 1/5 scale vehicles that have been built, and we are currently building our full scale model. It's, by the way, while you're operating it, the vehicle is nowhere in your line of sight, so you feel like you are flying. You're not enclosed in a cockpit. Pretty exciting. My wife said, no way. That's not anything else that's going in the garage. When we spoke with our community, which, by the way, at this point has grown to just over 1,400 people from 59 different countries, the greatest incentive to them was to be able to be part of an innovative and audacious project that had the potential to impact the lives of people or improve the world itself. And so, as I mentioned, we have today over 1,400 members from 59 countries, millions of messages exchanged, over 1 million hours of design and manufacturing that cost us nothing. What we were able to do, I believe, is find a way to mitigate the early stage risk and cost of R&D projects and drop the cost of supply down to near zero. Those HyperLoop vehicles that we showed that have outperformed anybody else, at least that we've seen publicly, cost us about $250,000 to build. We've won multiple international design awards, including from the Dubai Futures Foundation, where we were able to present to the Crown Prince of Dubai. And we have multiple projects in development. And so I would leave you with this. Today it's estimated there's about 3 billion people who are connected to the internet, and by next year that number is expected to double to between 5 and 6 billion people. That's 2 to 3 billion new minds that are going to be connected to the internet, who are going to have access to the wealth of information and knowledge available online, but also who are going to be able to bring their knowledge and experience to the table. And so if we could tap into that knowledge and expertise, and we could drive them towards solving these great challenges that we face, just imagine the possibilities. So thank you very much for your time. I will be here for the next few hours. I'd love to talk with anybody about our community. Thank you.